So these are the answers for the CCEA Chemistry Fact File 4.9 Carboxylic Acids and their derivatives. Question 1 says butan-1-ol reacted with an excess of propanoic acid in the presence of a small amount of conch acid. 6 grams of the alcohol produced 7.4 grams of the ester. Which of the following is the percentage yield of the ester? So first of all, number of moles of butanol. So butan-1-ol, formula mass 74, and it tells you 6 grams of the alcohol. So the number of moles is 0.0811. Now the theoretical yield of the ester then is 0.811 times 130. So you find the mass of the ester here, which is CH3, CH2, COO, C4H9. So 130, and then that gives us 10.54 grams as our theoretical yield. The actual yield tells you 7.4 grams in the question, so 7.4 divided by 10.54 times 100 is 70.2. We look at the answer, and that is B. Next, methyl propanoate may be prepared in the laboratory by the reaction of propanoic acid and methanol. So write the equation for the preparation of methyl propanoate. So there we have our propanoic acid and our methanol, and then the reversible sign, and then this is the methyl propanoate, and we get water as well. Then conch sulfuric is added to the reaction mixture. State one function of this acid in the preparation. So any of these, I would say it catalyses it. You could also say it increases the yield, or it pushes equilibrium to the right, or it absorbs water. So there's only one mark for that, but any of those would do. Then next question, propanoic acid has a boiling point of 141 degrees C, while that of methyl propanoate is only 79 despite its higher relative formula mass. Explain the difference between the two. So we've got the ester here and an acid. So of course the answer is to do with hydrogen bonds. So the hydrogen bonds between the acid molecules mean that it has a higher boiling point. The ester only has van der Waals. The hydrogen bonds are stronger than van der Waals, so the acid has the higher boiling point. And propanoyl chloride may be used in place of propanoic acid for this preparation. State two advantages of using the acyl chloride. Well, the first one is higher yield, or it's not reversible if you use the acyl chloride, or you could say it's faster, or you could say the other product is a gas. Okay, question 3. The following fat stearin is present in lard. It gives you the formula here. All fats look a bit intimidating, but don't be put off by that. You're just looking at, this is the main part here, and then each little ester bit on the end. So, when refluxed with potassium hydroxide, stearin produces a potassium salt of stearic acid, which is potassium stearate, and only one other product. Using the R to represent this, the CH3, CH2, 16, write an equation for the reaction of stearin with excess potassium hydroxide. So you can see here I've just circled those groups, and they're the ones which are going to be changed for R. So when I write that out, you see this whole structure here remains the same, but then the R groups are added on. With potassium hydroxide, it's okay, which we need 3 of those, and we end up just with the alcohol here, and then 3 RCOOK, that's the potassium salt. State the systematic name of the other product. Well, the other product here is just propane 1,2,3-triol. You should know it anyway. The methyl ester of stearic acid is present in biodiesel. Give the molecular formula of that ester. So it's going to be C19H38O2. And then the equation for the complete combustion of this ester. This is an absolute doozy, but just take your time, work through it carefully. So we've got 2 C19H38O2 plus 55O2 gives you 38 CO2 and 38 H2O. Okay, then we've got another big intimidating looking molecule here. It says trilinoline, which is rapeseed oil, may be represented as this structure. Write an equation for the formation of this trilinoline from 3 molecules of the fatty acid, linoleic acid, and glycerol, representing linoleic acid as C17H31COOH. So here is our glycerol, and then 3 of these linoleic acid molecules, and then we're just putting them in here. We've got the C17H31 attached. Okay. Oh, and the C double bond O from the acid is this end of the molecule that attaches. Okay, then explain why it's described as an unsaturated fat. It's because fatty acids contain the carbon-carbon double bond. And then this was quite a nightmare to fit in this gap, but here we go. Rapeseed oil can be converted into biodiesel by reaction with methanol. Draw the structure of this biodiesel molecule. So if you take the time to count them all up, you'll see that all of the carbons are there. Okay, 1, 2, 3, 4, 5, 6 up to the double bond, and then 1, 2, 3, and then there's another double bond, and then 1, 2, 3, 4, 5, 6, 7, 8, and then the carbonyl group, and then there's another methyl group at the end. Okay, and that's it. Thanks for watching.